Hi everyone, and welcome back to another BTLO Replay. Be sure to follow us on X, LinkedIn, or join our Discord server to keep in touch with the BTLO community. Links will be provided below. Guys, let's get started. So we have a lab called Follow My Lead 2. This actually is a three-part series, right? We do have FML1 and FML3. We decided to retire FML2. A lot of folks were getting stuck on this one. If you do look at the other solves, you'll see it's almost double or triple, right? FML3 and FML1. So definitely going to help you guys out. I did go to this lab last year, but I didn't get to finish it. But I think I'm more prepared now. It's going to be a digital forensic based lab. We have a scenario where we're not really doing like an investigation per se, but it's pretty much a junior being taught by a mentor, right? So it's going to be very interesting, and I think this is a great way to get your cool intro into digital forensic. So we're going to be using Arsenal Image Mounter, right, to mount these drives to our system. We have Kape as well too. We'll touch on that in the lab. And we have Timeline Explorer, which we actually do. Let me see if I remember. There it is. We actually do have a blog on Timeline Explorer, right? So definitely give it a read. It goes over how to use it. Small configuration. A lot of folks found this helpful, so definitely take a look at that, right? It will be linked in the description below. And also, since we went past it as well too, we do have our Insider Threat Matrix that recently launched, right? For those that are not aware, this is a framework built by and used for digital forensic folks, incident response folks, to help you really map out insider threats. As you can see, I helped out a little bit. But the framework goes into motives. Why would somebody do something, right? Is it psychological manipulation? Is it espionage? Are they leaving the company, right? And it goes into, go back over here, the means, the methods, right? Bluetooth, exfiltration over Bluetooth, airdrop, right, which is peer-to-peer, clipboard, FTP servers, could be potential emails, SSH, and preparation infringement, and then anti-forensic, right? Really clearing the trace, disk wiping, file deletion, etc. So give it a look. Since we're on the topic of digital forensic, framework is being well respected in the community. If you have any contributions, feel free to drop them. We'll link this below. But yeah, let's get back into our lab. There we go. So did a quick intro. I'm gonna boot up the lab now, and yeah, I'll see you guys there. All right, we're in the lab. Let's get started with question 1. Sadly, these are not numbered, but we'll try to keep a note. Question 1, I have set up a test machine for you to investigate. Open Arsenal Image Mounter and select Mount Image. Which file do you have to select to mount the VM? After you select the right file, select this device and write temporary and click OK. So pretty much this is a great walkthrough, and it's going to teach us how to become, a little junior digital forensic analyst. Again, this is not a comprehensive course, it's just a lab, but it's going to help us out. So we have the shortcut to Arsenal, I believe, right here. Yep. Just load that up real quick. You don't need to enter a license. Let's click OK. All right, and then there we go. Hopefully you guys can see this. Just put this over here. We're going to click mount this image as the question states. And where would it be located? Probably in the investigation folder. Yep, so we can see right here. Whoa, this is a huge size. Let me see. How much is that? Let's see if I can right click real quick. Translate to gigabytes. 24 gigabytes. Jeez. Interesting. All right, so you could tell this is one of the files, because if you look at the extension VMDK, that's short for virtual machine disk. It's a very common file format that contains like the virtual hard disk drive from virtual machines, right? So yeah, let's upload it and we should have a new drive. So for example, before I actually do it, can I open another folder? Yeah, I can. If you look at the PC right now, we don't really have anything mounted, right? We just have our standard C drive with Windows. So let's actually open this up. All right, making sure we're following the instructions. Oh, you know what I forgot to do? Oh no, I didn't forget. Okay, we're gonna put this right temporary. This is very important. It's gonna give us a little bit more right. See, yep, everything looks good. Let's double check. All right. Now this is pretty much just saying, and it looks like there was a previous file, August 21, 2023. So we're just gonna erase. Actually, we can remove. Yeah, let's start fresh. Let's start fresh. No issues. We're just gonna erase the previous changes that was made. Read only mode, but it's actually writable. Do you want to change the window disk property to make this writable? Let's see. Doesn't really mention that here. In the real world, right? Well, I mean, this is a clone, I assume, of the actual physical hard drive disk. We could technically, I'll just make it writable for now. And just so that there's not any issues. And as you can see right here, we just got 2 new drives. We have the system F drive, and then we have a E drive. Oh, so it's just a D too. Okay, there's the D. Yeah, that's the main one. All right, pretty cool. Super cool. Let's look back at the question. Which file do you have to mount? That will be this file right here. I mean, we could just type that out. It's not too bad. Follow my lead. This one VMDK. Nice. All right, I'll see you guys for question 2. All right, let's get started with question 2. What is the MD5 hash of this file? So I assume the file will be this virtual image right here. Now, the thing with this question, which a lot of folks get stuck on, and I don't blame them, right? If you remember, and we'll jump into these drives later on. For the meantime, I'm just gonna minimize this. We can minimize this, don't close it, right? So minimize that. I'm gonna open up this folder. If you see this drive, remember, it's roughly 44 or 45 gigabytes. You're trying to hash out a file that is this size. If I were to hash out anything else, it would relatively take me 1 second. But according to many students, this took them hours. Sometimes it wouldn't even compute at all, right? So what I'll do here, I'm gonna attempt it. Give it like a good minute. If not, I'll just show you the screenshot of the desired output, right? So there's 2 ways we could do it. Let me actually do it in PowerShell. You can also use cert-util, file hash algorithm MD5, and we could just filter for the file and see what that goes. So I have 2 CMDs running, or shells running, and you can see it's taking up a lot of resources. So I'll let it run in the background, but I'm just gonna flash the answer on the screen right now so you guys can see it and see the actual output. But yeah, so I'll minimize this and we'll come back to that later. All right, so that was question 2. Let's jump into 3. All right, question 3. How many mounts are there and what are the drive letters? So we could pull back up Arsenal. We see, wait, how many mount points are there? I guess we're mounting 1 drive, but there's many points, it's 3. So a drive. And again, if for some reason you have another thing mounted or you're messing around with the drive letters, please restart the lab and make sure it is these ones. Let's see, F. All right, see if that goes through. Sweet. All right, sweet. Let's jump into question 4. Right, let's jump into question 4. Remember what we did last time with Kape? Oh, this is making reference to Follow My Lead 1, which, check it out, pretty cool lab. Do the same with the OS drive for the image you just mounted. Choose Sans Triage and EZParser for the target and module options respectively. List the folder size of the parse data in MB. It's going to be very interesting. So I know we got 3 drive letters. We're going to be running Gcape, which is GUI Cape, right? Tool created by Eric Zimmerman to help triage data. One thing I learned is that you may have, again, that's 44 gigabytes of data. There's no way we could parse through all that. And most, if not all, the information, well, most of the information is meaningless, right? It's just waste. We're looking for that 1%. We're looking for that 3% of information that we really need. And why is this still running? Close this. Ask me later. But yeah, so what we're going to do, we're going to launch Gcape, which I believe is on the machine. Let's see. Is it here actually? Yeah, Gcape. Looks like it wants us to launch it. Okay, yeah, let's go for it. Now you can use Kape, the CLI for it, but we're just gonna keep it basic. Keep it very basic. I should probably fill in this answer too. So far, nothing has came. Now you see why this video must be made. A lot of folks get stuck on that. All right, so let's see. Gcape, give it some time to run, and then we'll jump back to it. All right, so Gcape is up and running. Some things we have to do before we start parsing it. We should probably make a folder. Yeah, let's make a folder real quick. We're gonna make 2 folders. I'm not sure if it's actually in Kape actually. Regardless, we're just gonna make some folders here. I think it's in Kape, but I could be wrong. I'm just gonna make a collect folder and a parse folder. Name is Kape parse. And then Kape collect. All right, cool. And then we'll just put the export information there. So again, out of that 45 gigabyte drive, we only want just, it's in MBs too. That's all we want. Just those small pieces of information to really build our case. Although we're being guided, this can help us in the real world. So target source is the source directory. So it will be the D drive. Yep. So yeah, this should look good. Let's give it a shot. And yeah, I think everything's good. Let's go. Yep, we're cool with that. All right, we are back. You can see it took roughly 700 seconds. You can do the math on that in minutes, but whew, been a while. All right, press enter to exit. We should have all of our files here. We have collect. Yep, get that MFT. Super cool, super cool. And we go to parse. Got even more finer detail here. So the question's asking us, where is it? Folder size of the parse data. So we could just do a right click. Property, and we can see 232 megabytes. There we go. Let's move on to the next question. All right, let's get started with question 5. I just realized as I'm going through this is rated as an easy lab, but there's roughly 25 questions, so 1 point per question. I really think these questions are worth a little bit more point, but I digress. All right, so wow, right here, question 5. Remember the last time we checked for MFT? Go and check on it this time and tell me the earliest entry. So obviously I already have it solved already, but we could still jump into it. So seeing that we have the MFT output, where is it? And right here, MFT master file table. It's like a database, right? That goes into the files that were added, deleted, and executed on the host system. So what we could do, go to tools, and I have a lot of this stuff up, which we don't need, so we could just minimize this. I don't know why we have 2G Kape, so get rid of that. Yep. And funny enough, it's still going. All right. Now I know actual forensic analysts, they do this in the field, right? Data acquisition and really priming everything up takes a while. Usually leave that for the juniors. But yeah, so what we could do, let's go to tools, Timeline Explorer. And again, if you need any tips on this tool, definitely check out our blog on it. We'll launch it. Again, another tool created by Eric, legend in the field. Drag that into here. All right, so it looks like we have our thing popped up. Let's look back at question 5. Remember the last time we checked at the MFT? Go and check it on this time and tell me the earliest entry. So obviously this will be the earliest entry right here, line 1. We can see the creation date. But oddly, this question is not asking for the creation date. It's actually asking for the file name, right, which is itself, MFT, right? So that has been placed there already. Let's move on to question 6. All right, question 6. We didn't add too much to this endpoint. How many total lines are there in the MFT? So you could find this right here. There are 328,756. I don't know if I'm even saying that right, but 328,756 lines. All right, so interesting. So I mean that's normal, it's average. I have seen MFTs with 600,000 lines. I have yet to see one with 1,000,000, but we saw the storage of this drive. It was roughly 45 gigabytes. Not your standard storage for most computers, so it could get real big. But obviously, this is just a sandbox environment. All right, let's move on to the next one. All right, question 7, which is, and I did end up actually turning off those 2 command lines. They were taking quite the resource, so just gonna place it here. Get this over with. Sweet. All right, so question 7. Let's look at the RBCMD output file. What 2 files were deleted? Now, this is an actual tool by Eric, but looks like it's been parsed without the tool, so really, really good module was utilized there. I'm actually learning stuff as I'm going through this lab. So we could go over here. Now, we don't want to, anything in Kape collect, right? We don't really have the correct tools to, again, parse these things you may see here. So just go to Kape parse. I think it's under file deletion. There we go. We have the recycling bin output here, and then we have these 2 files. So we have a Firefox installer exe that has been deleted, placed in a recycling bin, and then we have this VLC thing. I'm not too sure what that's for. Probably some VLC. perhaps some video program. But yeah, that's pretty much everything placed in that recycling bin. So that's going to give us our answer for, scroll down, 7. What 2 of those files were deleted? This one right here, and then this one. All right, let's move on to 8. All right, question 8. Let's take a look at that. Using the current output and the $J output file, what are the $I and $R file names for the Firefox binary we found in the previous question? I just came back, took a look at the lab creator's notes. So it looks like, according to him, any file beginning with the $I reference files that have been deleted, right? So when you filter, you see right here, okay. All right, I think I'm understanding a little bit more. Let me see if I can open this. Okay, I get it now. Right, so we see the source name. So that makes up the first part of the question, and then when you filter for that in here, right, you'll find this, $R, and then you just put those two together, and then you'll get the binary. Interesting. I don't have my whole head wrapped around it. Hey, I'm still learning, but quite interesting. So, quick recap, right? Go over here. You can see, open this up real quick. See that $exe. You'll copy that. You go to the $J output, paste that in there. You do a good filter. It will bring you this, which we already know, but also if you just get rid of those 2 digits in front, you'll get the $R right here, which is required for the question. So pretty much same name, just different prefixes. Interesting. All right, let's move on to the next question. Oh, my lab's expiring. Geely. Question 9. All right, let's see what we have here. Let's switch our attention. It looks like the VLC media player was installed. What is the Zimmerman tool that was ran against the prefetch file? So just from knowledge, if you go to program execution, we know that prefetch files, and the blog talks about it, they're used to indicate if a program has been ran. There is a tool called PNC MD, which is a CLI based tool. There we go. So this is a tool to check for prefetch files pretty much check the prefetch files. All right, going back to the lab. Let's see. Run against prefetch. Yeah, it's PECMD. Let me throw this in here actually while we're on it. And it's going over the executables that were ran. And I'm just VLC. Yeah. But no, I mean, that's actually very interesting, right? That module that does the parsing. We don't even have to run the tool, but you can see right here, right, it's talking about that VLC media player. We see it right here. It was clearly ran by it being on here. So very interesting. All right, let's get to question 10. So we know from question 9, right? PECMD is used to help output execution time for these programs. So you go over here, and I think this, yeah. So the rest of these I did not try, so it's gonna be new for us. What is the, oops, sorry, no, I lied. We are here. What is the last run? This is question 10. What is the last run time of VLC EXE? So we can see it right here. And we could just go with the source created. And that's going to give us a time of August 13, 2023, 8:52 assume AM if this is not UTC, right? So that's gonna be the time. The format, yeah, it's gonna be it's gonna be year, month, day, hours, minute, and seconds. Obviously, you can't see it from here. All right. Question 11. Let's check. Let's check this makes sense. Let's check this makes sense. Okay, that doesn't make sense. What was the date time that VLC exe was created on the endpoint? Enter the created timestamp you find in order. So with this, we could go back to MFT, right? Our general file system output, and then we could just type in VLC exe. Not sure if it's case sensitive, but regardless, I don't think so. We're gonna search this. Now, this question is quite interesting. There we go. And then we have the pre-fetch files proving that it was actually ran. Let's see, we have the dates over here, so let's look at this. And last modify. This is an interesting one, but Lab Creator wants us to go with this, right? Last modified 0x10, which is October 25th, 2022, and then last record change 0x10, which is August 13, 2023. Again, very interesting. Don't know the thought process completely on this one. Interesting. All right, let's move on to the next one. All right, question 12. Oops. What does the 0x10 and 0x30 represent in the context from the above question? Yeah, this one was quite confusing because the answer was, this is for the question 11. Last modified 0x10 and then last record change 0x10, I believe. Yeah. Now it wants us to look up 0x10 and 0x30. What does it mean? So let's jump into some articles I found online, and hopefully this could help us out. Okay, there we go. This is actually a better viewpoint. So file creation, file modify, record change last. So file creation goes into the time the file was created, which was kind of confusing, right? Because the file was created according to the logs on August 13, 2023. But then we're seeing really changed, right, a year prior, which is quite interesting. File modified, the state in time refers to when the file content was last modified on the volume. Record changed, the state in time refers to when the MFT record was last changed. MFT record was the last change. And the last access time, this date and time refers to when the file was last accessed by a process, computer, or user. This function has been disabled post Windows XP. Interesting. Yeah, let's jump to the next one. And then we have attribute 0x30 file name. Let's over the actual file together, size. Let's see. I'm back in the lab. So I guess, yeah, so 0x10 goes into file underscore name. 0x30 goes into standard information. All right, I actually just looked up even more detail. So it looks like created 0x10 goes into, standard information creation timestamp. So something that could be modified by the user, processing. So it could go into time stopping, right? Folks manipulating the time. Hence why it looked kind of funny to me when I first saw it. Not saying there's time stopping involved, but looked quite weird. And then 0x30 goes into the file name creation timestamp, and this can only be modified by the kernel or tools leveraging the kernel. So you're going to need special privileges. All right, so I found something very interesting reading this article. So proof of time stopping, you'll see that the sub-seconds will be zeroed out, but I saw something very interesting. So if a file has been time stopped, there will always be a value in the 0x30 column. This is because the 0x10 and 0x30 match. If they match, 0x30 will be empty, but if they differ, and there's a file in there, that means timestamping has potentially occurred, and then a timestamp and this will always be different. Interesting. Oh, okay, I see what they mean right here. It's empty, proving no timestamp occurred. But for the actual file, you can see as this differs. Interesting. Yeah, we'll save this for another conversation, but we pretty much got our answers. Let's move on. All right, question 13. You could probably guess which timestamp is the correct one, but this is digital forensics, and we have to make sure we know the user account Ron was the one to install the software. So we have to look for an account creation timestamp. What event log is it found in? This makes a little bit more sense, right? Because yes, the account at play is actually Roaring. If you actually go to, there's many ways to check this. Kape parse under collection. Oops. Go back a bit. Kape collect. D users Ron, right? The others are default users that come with the system. I guarantee they have a RID below 1000. So knowing this, right, and this can actually help us further clarify these creation dates, right? So we don't have to guess which time step is correct, that was the issue I was going through. Again, I'm doing this lab as I'm doing it. One event log you could find, and if you guys don't know where event log is located, obviously this is not going to be the event log of the actual user, right? We could probably see if it came through. Actually, that's a good point. Before I check that, I want to see something real quick. If it is located in the parse. Yes, we do have event logs here. And we have this right here. We could take a look at it. Throw that in there. But no, to answer the question, right, when you look at the event logs, so these are the standard one that comes with the system. When it comes to, let's say, account creation or authentication logs, this is mainly found in the security logs right here, right? If I full screen this, and some event IDs we could look up. See audit success. So pretty much login, credentials, audit success, and there's some creation stuff in here as well too. So let me actually make this a little bit bigger. Login, so on and so on. So very interesting. This was all 823 special login credential validation. Yeah. So the answer to the question will be security.evtx. And hopefully we could dive more into that. What happens to timeline? We could dive more into that. Whoa, we have a lot of stuff here. Let me just get rid of all these cell contents. We could dive more into that and other questions if it permits us. So pretty cool. Let's get rid of that real quick. And open this. We have some cool event IDs, and we could possibly filter for them. Hopefully the next question will allow us for that. But yeah, let's go on to the next one. All right, question 14, and as you can see, I have not done these. So it goes into what is the event ID for the account creation events. Let's look this up real quick. The event ID number for the user account creation in Windows is 4720. And yeah, let's run this through our Timeline Explorer, see what we can find. All right, so we're back here. I'm just gonna filter from here, 4720. And then we actually have two, actually. Interesting. I wonder if we could view the contents of these cells. Yeah, new account created. Okay, there we go. What's this? User. Oh, I think that's the, let's see what else they have here. Payload. Source file. As you can see, it was in the security event. Oh, actually, no, this is our source file. Never mind. Scratch that. Interesting. So, event ID 4720. All right, question 15. What time was Ron's account created? So, now obviously we don't. Let me see. We have a time account created. Eval user. I actually believe this. Wait, actually, I believe this one to be the account for Ron. Oh, it's right here. The name's right there. Yeah, I had a feeling. Okay, cool. So we have the proof right here. Woof. About to be in a guessing game. I was gonna also filter for it. It's so weird. Yeah. All right. Let's look at the time right here. So August 13, 2023. So yeah. So going back to the timestamp, right? Which I believe was here, or was one of these. It will be impossible. I think it's this one. It'll be impossible for this to be downloaded onto his system. Program files. Yeah, it's impossible. I guess that goes into when it was first downloaded, which then that makes sense, right? And then was launched a year later, but his account came out that same year it was launched. So his account was created, say 8 a.m. Right, looking at the time, and I should probably copy this. Let's say it was created at 8 a.m., right? And you go back over here, this was launched 52 minutes later. That adds up. That actually makes sense. This doesn't make sense. So this goes into the account. The tools already, or this program was already downloaded on the system. And correct me if wrong. VLC-exe, isn't that a built-in program? I could be wrong. I believe that's a built-in program, if I'm not mistaken. But regardless, it could be time stopping. Well, his account wasn't created, so it was already on the system, but we don't. Yeah. But if you look at the 30, it looks like it was. Let's see. Created, was downloaded 11 minutes after the account creation. So this actually makes more sense compared to looking at the 0x10, 0x30 makes more sense, right? You can't edit this. You need kernel level, only the kernel, or you need certain privileges compared to this. So okay, this is piecing together. Very interesting. All right, so we got our date. Let's try it out. Paste that. Sweet. Let's move on to the next one. All right, so next question, which would be question 16. Down here. Assume Rayon must have logged in after account creation, right, which was around August. It was August 13, 8 a.m. What is that EID? That goes into the event ID. I guess that's an acronym for it. We should look forward to showing the account has logged on. So if the account was created, we need proof that it logged on. Let's go to the next screen real quick. All right. So for a successful log on, the Windows event ID is 4624. So let's use that to filter in timeline. So look at the question again. It's not asking us if he logged in. It's already assuming he did. They just want the event ID that will be a good starting point to, I guess, verify. In that case, 4624. Nice. All right, question 17. What time did her first log on occur? Okay, so it's a girl. So now they want proof. Now I had issues. I couldn't 4624. Oops. Couldn't find anything here. Oh, what the? Wait, did I do the right one? Oh, it's 4624. What? I could have sworn I did that. Okay, whatever. Whatever. So we have logs here. We have 170 logs. Whew. What we could do. Actually, this saves us a lot of time. I could filter for. Let me. Log. Okay, I can filter for rayon here. Bam. That's actually pretty fun. And yep, log on, blah blah blah. Okay, now let's get the time. And then we see, so this is actually in descending order. So the earliest is August 13th, 2023 at 8 a.m. in the morning, but at 38 seconds. Right. And remember, the account creation for this account was at 8 a.m. 11 seconds. Right. So it's all lining up. Pretty cool. All right. I'm actually getting the hang of this lab. At first, I was like, ugh, where are we going? But no, this is pretty interesting. All right, sweet. Question 18. Looks like there's another log on event ID immediately after the first one. What does 4672 mean? Let's actually see if that's in here. 4672. Alright, nothing here. 4672. So I guess this is going to be an OSINT question. Super user account logons. Yeah, this one was an interesting one. The question formatting wasn't as clear. But no, it's actually administrator logon. That's for the question, right? I know it means special privilege assign new logon. All right, I'm back. I had to check the back end for this one. So it looks to be this administrative logon. Again, we could add. I could easily add another answer for this, but for the time being, we'll just leave it at this. It's a very old lab. All right, let's move on to the next one. All right, question 19. What is Ron's security identifier SID? I think we saw that earlier. All right, so I found it right here. Let's open this up. It was a better view of it earlier, but this will suffice. Oh, I'm missing a digit. All right. There we go. All right, question 20. We're almost done. Guys, if you're ever creating content, don't create easy labs with so many questions. It's a hassle. All right, let's look into question 20. It's important to know how long a user was on an endpoint. What is the EID for rain login off, and what time was it initiated? EID. Let's look that up real quick. It will be 4647. That goes into log off event ID. So let's jump back. With this, we could filter it. Let's do that actually. 4647. Oh man, we don't get any hits for it. 46. That's strange. Let me actually. Oh, I have all these filters. Let me just remove this. 4647. There we go. Yeah, that's another thing you gotta watch out for timeline. If you have you could have multiple filters and it can mess up the thing. Okay, so we have two. Oh, let me me guess. Yeah, Rayon right there. Oh, this is interesting. So she logged in 8 a.m., 38 seconds. Logged off 54, literally 53 to 54 minutes later. Interesting. Let's copy this. Good hour to do stuff on the system. Oh. Let's see what we got. Oh, the event ID. 4647. There we go. I think we're down to 5 questions and then we're good. I think I used already 2 extensions already, so interesting. All right, I think we're on question 21. Yeah, I think we are. Let's take a look at it. Have a look in one of the user assist files. It seems like the batch file name field is encoded, but the Kape parser has decoded it for us. What is the coding used here? User assist files. See where that's at. Oops. User assist files. Is that registry? Oh yeah, it's right here. All right, I'm back. I did some research. So when you get the batch file, user assist, throw it in timeline so you can actually see the batch file you name, and you can see right here when it comes to encryption. And then what you want to do here, let's just pick a random one. Do that. I hope I don't have to extend it again. Go to tools. Now the thing about this, here, I know what to do. All right, so we're on CyberChef because it's not actually on the box, surprisingly. Okay, Magic's not giving us anything. From what I see, wow, yeah, I did see some articles reference ROT 13 as a common encoding when it comes to batch file. I don't know how legitimate that is. It was on some forums, but I'm surprised Magic didn't pick it up. But you can see right there, yeah, it is actually encrypted and, or sorry, encoded, I should say. It's encoded in the ROT 13 algorithm, and we just decoded it using the ROT 13 algorithm. So there you go. Very, very interesting. That was actually one of the most interesting questions here. All right, let's jump back to the lab. ROT 13. Nice. All right, question 22. Have a look at the console log for the strum output. What is the likely reason strum wasn't parsed, and what needs to be done? Now the strum is located, I believe it's in, right here. There we go. Is it in CSV? It's in logs. Let's take a error processing the file. Means the database is dirty and must be repaired. Okay. All right. Yeah, dirty and must be repaired. All right, let's give that a shot. I didn't even know they had the log there. Is dirty and it must be repaired. There we go. Yeah, this question got a lot of folks tripped up, but looking at it now, it's actually very simple. I didn't realize how easy it was. All right. All right, question 23, I believe. And it doesn't have a format, which is strange, but I think I know why. Oh, is this the format? This is very, very weird. All right. What file would you give a good overview over interesting items in the registry? Yeah, look, that makes my head hurt. So let's go to the registry. The Kape thing is really, really cool. Registry. So obviously this file fits the format we saw earlier, but hold on. Oh, I see. Okay, there we go. Okay. All right. Question 24. Almost done. The run and run once key are often used by adversaries to maintain persistence on an endpoint. List all the value names for run and run once, and then answer yes or no whether one of these keys is concerning. List alphabetically, and if a value name repeats, only enter it once. All right, where do we find these run keys? Let me see. Oh, hold on. Actually, what am I thinking of? In this file. Yeah. Throw that in there. So we have 200. Why should it say visible lines 230? Do I have a filter on here already? I actually do. Let me erase that. Okay. See if we can filter out anything that has run in it. And then we're going to look into the value name. Yep. That's what I was looking for. Interesting. Whew. It's been a good check of time on that. Yep. Okay, cool. So we have one program here. And it wants it in alphabetical order. So M N N O P. There we go. Cool. And yeah, this does look quite suspicious. All right, the final question, question 25. Have a look at app component cache. The app, I'm just going to say the app CC, also known as shim cache, helps Windows determine if a binary is compatible to run. It will often shim the binary before it's executed. What is the timestamp for the VLC hyphen all this stuff binary? Does it fit the description and timeline? Ooh, all right. EZParser, which is actually going to this lab is a very, very important tool. Let's see. App Cache. Yeah, let's go with this. This has 331 lines. We could filter for. Let me just filter here. Wow, timeline is powerful. Look at all these CSVs we have open up. Let's go do VLC. It wants us to do the one, yeah, this one right here. I guess it just wants the timestamp, last modified time UTC, which actually does fit it because Ron logged in at 8 a.m. 11 seconds, and then no, count was created at 8 a.m. 11 seconds, logged in at 8:38. 8 a.m. at 38 seconds, and then roughly 10 minutes later, you have this popping off. So let's give this a shot. And then, yes, it does fit the timeline. Copy. There we go. What a long lab. Been on this for like good 4 hours. Good 4 or 5 hours. Interesting. I learned some things. Learned a lot of cool things, especially when it came to the Kape. Yeah, good series. If you find this interesting, check out FML1 or FML3. Yeah, thanks for watching. Be sure to like and subscribe to never miss a video. In the meantime, remember to join our Discord. Tune in every Friday at 6 p.m. BST for BTLO Replay. Thanks, everyone. See you next time.